Timber Talks is brought to you by Wood Solutions. Stay up to date with the latest in timber, the building material that is strong, safe and sustainable. Here is your host, Adam Jones.
The project 752 High Street is a innovative 5-storey CLT project set to start construction in October 2019. The project had multiple challenges in design and construction that has required really innovative solutions from the project team, who we're lucky to sit down with today. So we're going to be speaking with Paul Gardiner from Gardiner Architects, Nathan Benbow, the engineer from Vistek, and the builders Alastair, Holmes and Chris Wood from Sinjen. So in this part 2 of this 2-part series, we're going to be talking about how to achieve efficient construction for the project, the importance of managing moisture in design and construction, and all the lessons learned from the project team. Without any further ado, we'll get into the discussion with the project team for 752 High Street in Thornburry.
It's prefabrication, but it's not mass producing the one object. Yeah, so the design scope is still there to do anything. You're just using the systems to make it easy to build.
Yeah. I think that's
why we're attracted to it.
Yeah, that's a really key point. You know, we can prefabricate and automate and all that, like a generic product, generic stock, but a prefabrication of a intricate design or a custom design, as you know, 752 High Street is, and a lot of the other projects we work on is, that's a lot more of a challenge, you know, than for example, prefabricating wall panels on 25 townhouses compared to prefabricating wall panels for something as unique as 752 High Street. They're far different. Far different.
So that would be like the car industry. You want to be like the car industry, but producing a custom-made car every time it spits off the machine.
Otherwise, we'll all be out of a job, won't we?
Yeah.
But having the benefit of other subcontractors coming on board and being able to use that information to accurately quantify and reticulate their service through the building, I think is important as well, which in turn will, you know, hopefully bring the cost of buildings down, because that contingency factor that subcontractors have in their quotations for those exact reasons are null and void now. And
all the defect costs, because your plumber comes in and goes, I'm just going to put this here because I don't care, and leaves.
1645 bends, and I know that's exactly what I'm going to be using. So, you know.
I understand that construction is going to start pretty soon. So what are some of the thought processes that you're going through to ensure it's going to be successful and optimised through the construction period?
1,000,001 things.
What are we doing here?
Yeah, it's obviously the site itself is a tough site to build on. You know, even a conventional build, it's a tough site to build on. You've got two streets. You've got two streets. You've got trams. You've got power lines. You've got. So I mean, you know, it is a tough site, but really the traffic management, the scheduling, the coordination, the crane placement, the all those sort of things are the first things, you know, that come out or come into play when we start to plan these assemblies. So. You know, it's not as easy as parking a concrete pump there for half a day and you've got a deck. It's precise scheduling of deliveries and understanding what you can really achieve in a day or realistically achieve in a day. So you're not blowing money away.
That's a really important point. We're working through shop drawings and finalising shop drawings now for panels that will be delivered in February and installed in February. So we can't, if we call them up too late, we get penalised because we're sitting around on site not doing any work. If we book them in too early, we get penalised because we have to pay storage costs. So that initial stage of construction is very, very important to get the timing right. So, you know, the day that those panels come off the CNC router, they're on a truck and they're down to us and we're putting them up the next day in an ideal world.
And we go further than that to coordinate other materials to be there on site before we put a lid on for the next lift. So there's a lot of planning with a lot of subcontractors and a lot of suppliers, and it has to really work like clockwork. We know it never does work like clockwork, but we try our best to use this time up front to be able to really plan and have contingencies in place for things that would inevitably do go wrong. We have arrangements with manufacturers for storage, and we negotiate, certain prescribed times around certain deliveries where we have storage arranged. But as we all know, that a week or two on site, a bit of inclement weather, those times can blow out very quickly. So we want to make sure that we're responsibly calling up this material as we need it, and it's not not being stored incorrectly or for prolonged periods of time.
Just back to some discussion earlier about foreign supply. That's probably the biggest challenge with that, because you're putting it on a ship for minimum 35 days, mostly 40 days, and to get that to land right, come through customs and arrive at site on the correct day, that's pretty hard to do. Yeah.
Or at your off-site facility with rental on containers after 2 days. So it's a very, very tough ask, because you are relying on other structure as well to stay on critical path, so that you can pull this material on site when it needs to come. But as we know, it never really goes to plan, so that needs to be planned for.
So the advantage of once the CLT is going up, it'll go up floor by floor, roughly weekly or whatever, fairly quickly. And then, of course, there's no props or anything, so all the other subcontractors can come in. So you really need to have your box of lights and your door hardware and your tiles and everything sitting somewhere ready to go, because it all happens more quickly. Yeah.
And that's why we talk about the water mitigation and water egress through these buildings is so important, because if you do want to have those trades follow on from structure that early, you really need to be managing that very, very closely. So you don't want to be covering up wet timber. So that's something that we're doing a lot of work on at the moment, and understanding how we mitigate that water egress through buildings, these particular buildings.
We were looking early. The industry is not at a real prefabrication point yet, because we spent a year really thinking we're going to do the CLT panels, we're cladding it in brick, which was an architectural decision, so brick slips. And the idea was we make the panels, the brick people would come and bricklayers would lay inside a factory, the whole panels would come, and then they just all slot together. And the logistics of that, and even the technical issues about how panels go together and tolerances is just not there yet. And so Alastair pulled the pin at some point on that.
I think it's important to note that particular model, or that particular prefabrication model, was very, very difficult to achieve from a weatherproofing and a fire rating perspective. We did a lot of work early on and worked out how we could, potentially make this happen. But because there was no access to the inside face of that rain screen, it made it very difficult to ensure that the building was adequately fire rated and protected from the weather.
Yeah, like you say, Chris, this project, the panelisation alone creates its own challenges, because it's not just conventional platform construction. In some areas we have panels that essentially there's sort of semi-balloon construction in certain areas, so that we've got deep beam panels, but then that just creates more issues with the fire rating and the weatherproofing of those joints.
Chris, can you talk a little bit about the optimisation for the critical path?
The critical path is always the structure. So, but we're sliding in the other elements into that critical path, but being very mindful of not tying up resource so that structure can't continue. So those are there's a few things we're working through at the moment to try and work out how we can simultaneously keep those two line items running on a critical path. But yeah, those are the early discussions that we work through as a core group.
Is logistics a whole new challenge that really wasn't there for conventional construction? And who is responsible for really taking control of logistics for projects like this?
Well, as architects, we get involved early on in things we've never ever heard about, like craneage analysis and stuff like that, because we have to actually understand how it would be built, which is why it would have been better to have Sinjen on earlier. But anyway, over the last year we'll work through it. So you have to understand how it's going to be built to actually draw it and understand the costs.
Yeah.
And it's not normal for us to be so intimately involved in that build process.
Yeah, I think that's exactly right. In answer to your question, Adam, yeah, we are learning a lot about logistics and how that affects the build, and then that often goes back into the design where we need to readdress the panelisation or whatever it may be to make those logistics either possible or economical. So we're learning about things that, truck sizes, crane sizes, site layouts and stuff that in this sort of build, like 752 High Street, it wouldn't have been, if it was concrete and steel, you wouldn't have had those considerations, or you wouldn't have paid it as much attention because it's a lot more fluid in that more traditional form of construction.
Fantastic. All right. So we might just go through a round of hearing about all of the lessons learned on this project, starting with you, Paul.
Well, I think the lessons learnt would be that, we do need to engage specialist engineers and builders and everybody early on, and the supplier of the engineered timber early on to understand. So Wood Solutions have really helped with that. I know you just work for them, but without them we probably wouldn't have had the knowledge to have been confident to keep going on. We probably should have put more fees in, architectural fees, but anyway. The lessons probably would be we're being a little ambitious trying to make the whole building prefabricated. We need to pull back. And there was another lesson would really be we just have this purist idea of what's all timber, whereas really engineered timber industry is often hybrid, as Nathan was saying, and the hybrid system is just as good. If you need to add a steel beam somewhere, it's not forgetting your purist ideals. Yeah, and that's probably the way it really should work.
Do you think there's potential for full prefabrication for the right project when it comes along?
I think full prefabrication only really happens when you've got a standardised floor plate. Yeah, and we haven't done that on purpose here, and it took us a while to realise that it wasn't really going to work easily. But I don't see, because you can get BIM systems and CNC machines cutting panels, and once the model's there, I don't see restrictions to any building really, except in height and structural capability. I don't see too many restrictions with any sort of building. In fact, we're looking at doing 3 houses at the moment down in the country, and we're going to use LVL, or they're sort of composite cassette roof systems where you've got exposed LVL ceiling, then a manufactured cassette. They'll be insulated and the roof on, and then the whole lot just dropped on a stick frame. And the local builders are realising, that's not a bad idea. Yeah. So it's opened up our thinking about where we might use it. Yeah. Except the client doesn't really like CLT look of it, but that's another issue.
I suppose lessons learnt from me personally would be really the fire rating mechanisms and the scrutiny that timber buildings are copying in Australia. We see conventional builds that have nowhere near as much fire rating mechanisms involved than a timber building, whereas in reality some timber buildings actually would perform better under fire duress than a standard construction. So I think from an estimation and a pricing point, I think it's important that people really do their research and understand what the fire engineer is going to want and what he's going to require to have if you want to do a multi-residential timber building. And just to touch on the other one would be moisture management and how you keep that timber structure breathable and you don't get a leaky house, so to speak, syndrome with these timber structures. So I think that they're the two big takeaway points for me when looking at a larger scale timber project.
My learnings would have been similar to Chris's, just in the acoustics and fire rating and fire management of the building. I think that over the journey of 752 High Street, the element I find most excited about, in addition to the massive timber, is the whole BIM modelling and, just imagining what that's going to be like moving forward, both in massive timber construction and conventional construction. I think that's pretty exciting from a trade procurement and supplier procurement perspective, right through to estimated quality assurance, design. Obviously, I think that's a really exciting element of the industry at the moment.
I guess for me, with the stage we're at, it's probably more seeing some of the things I've learnt and some others have learnt in the industry being implemented on this project, and seeing how that actually goes and assist with the construction process, like Chris mentioned, making it weather tight and avoiding any durability issues during construction. And then from a structural point of view, seeing how we're actually introducing our first CLT band beam or pure band beam. We've had a project where we called something a band beam in the past, but that was more to appease the architect, and it wasn't a pure band beam in the sense of the word. But
the architect's not listening.
That's all right. I think you'll forgive me.
I didn't know you ever appeased it.
But it'll be really interesting to see how that goes, and also how difficult it is to construct as well. And then also there's some quite big, deep beams in this project that don't have sort of floors restraining the top flange, which will be in compression, so therefore prone to lateral torsional buckling. So we've obviously put in some measures to prevent that, but that'll be really interesting to see how they perform.
Hopefully they perform well.
They'll perform perfectly.
Oh, okay.
$752 High Street was a project that used the DTS approach, which is now extended to all building classes in the 2019 updated National Construction Code. If you want to learn more about the DTS approach and how timber buildings can meet the acoustic and fire requirements as specified in the Construction Code, I suggest you download Technical Design Guide number 37.